All right, this asks, the philanthropic organization expects about a 5% success rate when they send fundraising letters to the people on their mailing list. And here, the sample statistics from each simulation, whether the size was size 20, 50, 100, or 200, and their mean and standard deviation are given below. So when the size, we have sample sizes of 20, 50, 100, 200. We have the mean. And then the standard deviation. Okay. A asks, according to the central limit theorem, what should be the theoretical mean and standard deviations be for these sample sizes? Okay, so the theoretical mean, the mean for each one of these should be 0.05. We're expecting a 5% success rate, so the mean should be exactly 5%. The standard deviation should be the square root of p times q divided by n quantity square root. So for 20, that would be 0.05 times 0.95 divided by 20 square root. And here we would have 0.0487. Okay, and then likewise we can calculate it for 50 and 100 and 200. 0.05 times 0.95 divided by 50 square root 0.05 0.95 over 100, and then 0.05 divided by 200 quantity square roots. And so each of these, let me just here we have 0.0308. 0.0218, and then 0.0154. Okay, and we can see that these numbers are pretty close to what we observe. How close are these theoretical values to what we observed in the simulations? So everything is pretty close to 0.05, and the standard deviations are very close. So the answer there is very close. C, it says, looking at the histograms in exercise 1, at what sample size would you be comfortable using the normal model as an approximation for the sampling distribution? So, So looking at this, I would say around a sample size of 200, we can use the normal model. It looks like it's pretty skewed for 20, 50, and 100. So looking at the normal model, I would say sample size of size 200. And then for D, it asks about the success-failure condition. And so with the success-failure condition, it says that n times p should be greater than or equal to 10, and n times q should also be greater than or equal to 10. In this case, p is 0.05, q is going to be 0.95. So we're not going to really check this one so much. But For a sample size with n equal to 20, 20 times 0.05 is equal to 1, so that's not good. For 50 times 0.05, we get 2.5, so that's also no good. At 100 times 0.05, we get 5, also no good. And at 200 times 0.05, we get 10. So this one works. So the success-failure condition also confirms that only when samples are of size 200 can we use the normal model.